Well, hi, this is George Arrington. I used to teach math and computer science and physics, and I wanted to show you today the derivation of the quadratic formula. Well, a lot of times in mathematics and science, we end up with an equation that needs to be solved for the variable, in this case the variable's x, that's in this form where we have a number multiplied by the x squared term, and another number multiplied by the x term, and then a constant number, and all set equal to either some constant or, in this case, we've set it to 0. So how do we solve for this? Well, if it's a nice quadratic equation, we call this a quadratic equation. If it's a nice quadratic equation, we can easily factor it into integer coefficients of the x terms, and then just simply solve it by setting each of those binomials or two-termed polynomials to 0 and solving them separately. But in a lot of cases, the factoring of this particular quadratic equation is not so simple. So in those cases, and actually in any case, we can always use this formula, which is called the quadratic formula, that all high school students have to memorize, where we say x is equal to negative b plus n minus the square root of b squared minus 4 times a times c, all of that divided by 2 times a. And where a, b, and c, I'll go back up to my original quadratic equation, are the a is the x squared coefficient, b is the x coefficient, and c is the constant term. So anytime we want to solve that, we can plug it into here. And this will give us, sometimes it will give us whole number or integer values, and sometimes it will give us irrational numbers where the square root of 2 or the square root of 5. And even sometimes we'll get imaginary or complex roots where the term inside the square root symbol is a negative number. So this is a great tool for all mathematics and science students to solve those types of equations. Well, how do we derive it from the original equation? Well, the way we do that, and here's the original equation once again, the way we do that is by making use of something called completing the square. And what completing the square is, in order to explain that, let's look at just a simple two-term polynomial or binomial and square it. So if we wanted to square that thing, we would treat it like this. X plus n squared would be x plus n times x plus n. And now, how do you multiply that? Well, you know, if you multiply two numbers, you just multiply them by each other. But when you have a binomial, when you multiply it together, you have to multiply each term in one of the binomials by every other term in the other binomial. And for those students who have learned this, we sometimes call this FOIL, F-O-I-L, where we multiply the first terms, in other words, the x and the x. We multiply the outside terms, that would be the O in FOIL, which would be the first x and then the last n in the second binomial. And then the I would be inside, so F-O-I, the I would be inside, so that would be the first n and the second x. And then the L in FOIL would be last, so that would be n times n. And so that looks like this. That would be x squared plus nx plus nx plus n squared. Or if we want to simplify that a little bit, combine the terms, we get x squared plus 2nx plus n squared. Okay? So the one thing that you want to notice here is that in order to have, I'm going to use my little cursor here, if you want to have a perfect square where, again, let me just zip back up to the top for a second. where you have something multiplied by itself, x plus n squared, you have to have it in the form of this, where you have a 1 for the x squared term, something for the x term, and then something else for the constant term. And the way we look at this is we say take half of this part right here, take half of this, and then square it. So in this case, half of 2n would simply be n, and then when you have n squared, that's n squared. So in order to get a perfect square, we have to have something in this form. Okay? So let's and here's a restatement of what I just showed you, that n squared is 1/2 of the x coefficient, and then the whole thing is squared. Okay? So that's how you complete the square. Okay, so with that knowledge, let's try to take our quadratic equation and solve for x using this method of completing the square. Okay, excuse me. So the first step we're going to do to try to simplify this equation here is we're going to divide everything by a in order to get a coefficient of 1 on the front. So we're going to divide this by a, this by a, this by a, and 0 by a. So we're going to divide both sides by a, and that looks like this. So we have the a divides out to 1. We get b over a times x, and c over a as our constant term, and then 0 divided by a is simply 0. The next step is then to, let me go back here, since this is not in the form of, remember, take half of this and then square it, this is not in that form necessarily. So we're going to take this and move it over to the other side, and that looks like this. So we have x squared plus b over a times x plus nothing here yet is equal to negative c over a. We brought the plus c over a to the right side of the equation, and it becomes negative. All right. So now, to complete the square, remember we have to take half of this thing and square it. So half of the b over a and square it. And that looks like this. b over 2a, that's half of b over a. 1/2 times b over a is b over 2a. So b over 2a squared would be b over 2a times b over 2a. And that gives us b squared over, now 2 times 2 is 4, and a times a is a squared. So that gives us b squared over 4a squared. And what we're going to do is we're going to take that and we're going to add that to both sides of the equation. And that looks like this. So we have now x squared plus b over ax plus b squared over 4a squared, which is what we just figured out, is equal to negative c over a plus b squared over 4a squared. So what you do to one side of an equation, you have to do to the other side of the equation, all right, to balance things out. Okay, so what's our next step? Well, our next step, actually, we have to do this in two parts. You can do it at the same time, but to make it a little bit more plain, simple, I'm going to do this in two parts. I'm first going to look at the left-hand side, and then we'll look at the right-hand side of the equation. So for the left-hand side of the equation, recognizing, let me back up one step, recognizing that this is in that form of x squared plus 2nx plus n squared that we showed before, we can say, oh, well, this is simply x plus b over 2a plus b over 2a quantity squared, okay, or this right here, okay, x plus b over 2a, the whole quantity squared. And we like we like this because now we can later on we can take the square root of both sides, and this will leave us with a linear x term, an x all by itself to the power of 1. Okay, so that's the first step in solving this. Now let's look at the right-hand side of the equation. The right-hand side of the equation, first of all, we have to, let me move it back here. We can't combine these two fractions together because they don't have a common denominator. So what is the common denominator between a and 4a squared? Well, it's simply 4a squared. So if we want to make this 4a squared, then we're going to have to multiply both the top and the bottom by 4a. Okay? 4a times a is 4a squared, and 4a times c will be 4ac. And that looks like this right here. Okay? So we have negative 4ac all over 4a squared plus b over 4a squared. Okay, so what I'm going to do now is I'm going to, just to make it look a little bit nicer, a lot of times in algebra we don't like to have a beginning with a negative sign. I'm going to switch these two and put them together. And that looks like this. So b squared over 4a squared minus 4ac over 4a squared, and that becomes this. B squared minus 4ac all over 4a squared. And if you're thinking ahead, this term right here, b squared minus 4ac, you might remember, is part of that quadratic formula that we saw. So you may be saying, hey, we're getting close. And indeed we are. So we're almost there. Let's see what we do next. Well, what we do next is we take the square root of both sides. Okay? The square root of x plus b over 2a quantity squared is simply x plus b over 2a. And on the right side, we take the square root of that whole thing that we had before, of the b squared minus 4ac. We have the square root of that. And remember that when you take the square root of a number, when you square a number, it could be either the positive or the negative that would equal the number. For instance, if we take 4, for instance, the square root of 4 could be 2 or negative 2. Plus 2 squared is 4, and negative 2 squared is 4. So we have to treat both possibilities here, so plus and minus. And then if we take the square root of the bottom, which was 4a squared, we're left with 2a. And this is good news because you can see the 2a over on the other side as well. Okay, so pulling the constant term over to the right-hand side, we have negative b over 2a plus and minus the square root of b squared minus 4ac all over 2a. And our final step is to combine these two, since we do have a common denominator, and therefore we're left with the famous quadratic formula. X is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a. Okay? Well, I hope you enjoyed that presentation, and it's something we use all of the time in mathematics and physics and other sciences, and that's where it comes from. So, hope you enjoyed it, and we'll see you later.